Hi, Mrs. McTaggart here. In this video we are going to be looking at polynomials, lesson 3 and 4, fully factorising polynomials. I'm going to split it into two, which would probably be done during a double period in class. Okay, so before we get into some actual examples, I want to talk about two things. First of all, we're going to talk about the remainder theorem. So when your polynomial is divided by a factor, then the remainder is f of a. So in a previous example, I asked you to maybe find f of 2, and you put 2 into the table and worked your way through, and the number you got at the final end was the exact same as what you would have got by substituting in 2 to the original polynomial, like the nat5 method. The second thing I want to talk about is the factor theorem. This is probably one of the most important bits about polynomials because they ask you all the time to prove that something is a factor. So if you go in your nested table and you come down and the number you come out with at the end is 0, then that means your remainder is 0. And it means that whatever you're divided by in here, let's call it A, and you came out with your quotient, it means that it factorises perfectly with no remainder. And it means that this thing here is a root of your equation. So x equals a is a root, and in turn, x take away a is one of your factors. So that's one of the things it divides by nicely. And your fully factorised answer would be your x minus a times your quotient. No remainder at all in this one. Let's have a look at an example in action. Okay, my first example asks us to show that x minus 4 is a factor of this polynomial. Now, the x minus 4 sometimes will appear in a bracket, sometimes it won't be in a bracket. Don't worry too much about it, but just be aware it could be either. So the number that goes in the front of the table comes from that bit there, which is a factor. You put that equal to 0, which gives us x equals 4. So we put a 4 at the front of the table. And most people start to just realise, well, it's the opposite of what it says in the bracket. If it says minus 4, we use positive 4. So from there, we have no missing terms in our polynomial. So we have got a 2, a minus 9, a 5, a minus 3, and then a minus 4. And we're going to bring down the 2. Okay, so then we times by 4. 4 times 2 is 8. Combine those two together, so minus 9 and 8 is minus 1. Multiply it by 4 is minus 4. 5 minus 4 is 1. Multiply it by 4 is 4. Minus 3 and 4 makes 1. Multiply that by 4 is 4 again. And then the end two terms, when they add together, it gives you 0. Now, our remainder is 0. That meant it divided perfectly by this factor. So we have a statement to write that's really, really important. So when it says show that something is a factor, we have to write the following. So we write, first of all, remainder equals 0. You could also write f of 4 equals 0. It depends what your teacher prefers you to do. I always just go with remainder equals 0. So since the remainder equals 0, that means that x minus 4 is a factor. Now, I always add this extra wee bit just out of practice, and I add on the x equals 4 as a root, because when you went on to solve x minus 4 equal to 0, you got x was 4, which is a root of this polynomial. You don't have to write that last wee bit, but on the rare instance when a question asks you to show that something is a root rather than show something is a factor, it just means that you don't write the wrong statement. You've got a wee bit of both in. So I'm putting both there, and you must write that. But as I said, this last wee bit here is your optional bit, okay? But I will dump it into my class that it's good practice to do it, just in case. Okay, now let's just practice what we're doing before. We're not going to fully factorise this one, but we are just going to write out what it is and what our quotient is for a wee bit of revision of that. So we divided by x minus 4. So this gives us the solution of x minus 4 for your first factor. You've got 4 terms here, so this is going to be a cubic. So 2x cubed minus x squared plus x plus 1. So that is it factorised. It's not fully factorised though, but the question didn't ask us to do that. The question asked us to just show that it was a x minus 4 is a factor, so that's probably where we should have stopped on that question. Okay, so in this question we have to show that x plus 4 is a factor of the polynomial and hence factorise fully. So first thing first, because it says x plus 4, putting that equal to 0 would mean minus 4 goes out the front of our table. There are no missing terms in a polynomial, so we've got 2, 3, negative 18 and positive 8. Bring down the 2. Right, 2 times minus 4 is negative 8. 3 take away 8 is minus 5. Multiply it by negative 4, it gives you 20. 20 and take away 18 is 2. Multiply by negative 4 is negative 8. And at the end they cancel out, so you have got 0. So to show that bit, so we write remainder equals 0. So x plus 4 is a factor. And then the extra wee bit I always put in is x equals minus 4 is a root. So now to factorise fully, so we divided by x plus 4 for our factor. So your first factor is x plus 4. Then you write out your quotient, which is 2x squared minus 5x plus 2. And if there's 3 things there, then that's simply going to be a trinomial. And then this trinomial here is going to factorise 2x and x. Numbers that multiply to 2 are 2 and 1. I'm going to put the 2 here because that would give 4 on the outside numbers and 1 would give 1 on the inside numbers. To get negative 5, they both have to be negative. So there it is in fully factorised form. Those 3 brackets multiplied together would take you back to the polynomial I gave you there. So if a question says to just show that something is a factor, we stop at the statement bit here at the right hand side. If it asks you to factorise fully, you then go that extra step and write out your first factor and your quotient. And common mistakes that we see are in exams are pupils quite often forget to write out their first factor and they just write out the quotient and then try to factorise that. So remember, a quick look at the end, your first 3 terms should all multiply to 2x squared, which they do. Sorry, 2x cubed. You've got x times 2x times x. That gives you your 2x cubed. So we know we've got the 3 factors there. Okay? So if you get access to the TJ Higher textbook, I would recommend going to page 113 and trying question 1. And then come back and I'll show you the next couple of questions that will let you go back and do question 2. So number 3 wants us to fully factorise this polynomial. Now, first thing to notice is they've not told us what to put out the front. So I'm going to start by just drawing my table. I have no missing x terms, which is good. So I've got 2, 5, negative 28 and negative 15. We're going to have to do a wee bit of trial and error here, folks, with the number that goes at the front of the table, and it is to do with the minus 15. So the number that goes at the front of the table has to be a factor of minus 15. So we've got loads of options here. We've got 1 and minus 1, we've got 3 and minus 3, we've got 5 and minus 5, and then you've got 15 and minus 15. So which one do we start with? I'm certainly not going to try the 15s. I am going to try minus 3. Okay, because there's some negatives going on in here. So let's try minus 3. If I bring down the 2, gives me that. 2 times minus 3 is minus 6. 5 take away 6 is minus 1. Times that by negative 3 gives me 3. This will give me negative 25. And I can see straight away that's not going to work because that would then put 75 in here. And I want these two to make 0 to be able to fully factorise it. So that was no use to me. So, but what I'm going to do is before I rule out the number 3, before I rule out the minus 3, I'm going to try it with positive 3 instead. So bringing down the 2, 2 times 3 is 6. 6 add 5 is 11. 3 times 11 is 33. Here we go, this is going to work. 33 minus 25 is 5. 3 times 5 is 15. And then plus and minus 15 end up with 0. So you won't always get it first time, alright? You maybe have to play around. So this fully factorises, so I'm going to write my statement. So I'm going to write since remainder equals 0. That means that x minus 3 is a factor. And x equals 3 is a root. Right, now I have to fully factorise it. So, I was going to try and move that all up there. Right, so to fully factorise it, my first factor was x minus 3. Then my quotient would have been 2x squared plus 11x plus 5. Okay, and then we're going to factorise this. So, first bracket stays as it is. Second bracket will have a 2x and an x. And you have all your different ways of factorising. I'm just going to do it by a wee bit of trial and error. Numbers that multiply to 5 are 5 and 1. And the 5 goes there and the 1 goes there. So the outside terms would give me 10 and the inside would give me 1. Everything is positive. So there is my polynomial fully factorised. Okay, into 3 brackets. Right, we're going to try this example here. Now, this example, again, I haven't told you what to use as a factor, but I do have a little handy trick that I always do if I'm really struggling, because 12 has got an awful lot of factors. When you write out these numbers, 2, positive 11, positive 10, negative 11, and negative 12. Something that could help you is see if all those numbers there add up to 0. Then the number 1 will always work out the front for your table. Okay, trust me, it definitely works. But obviously I could have used 1 and negative 1, 2, negative 2, 3, negative 3, 4, negative 4. So there's so many factors, there's 6s and 12s as well, that for the time it takes you to quickly add up those numbers, they add up to 0. I know that number 1 will always work in the table. So I'm going to just use the number 1. Let's bring down the number 2. 1 times 2 is 2. 11 add 2 is 13. Times 1 is 13. Add them together. That gives us 23. 11 take away 23 is 12. Times it by 1 is still 12. And there, look, it works. 12 minus 12 gives us 0. Right? So what we've got from there is we have that our first factor was x take away 1, because it's the opposite of what you've put in. Remember, if you've put positive 1 in the table, it becomes minus 1 when you put it into the bracket. Now your quotient would be 2x cubed plus 13x plus 13x squared plus 23x plus 12. Now, I can't factorise 2x cubed very easily, but what I can do is I can go do another nested table using that polynomial. So, let's draw out a new table. And we're going to put in 2, 13, 23 and 12. Right, they definitely don't add up to 0, so I can't use my trick. So I know that 1 doesn't work this time. What about trying negative 1? So I'm going to try negative 1. Bring down the 2. 2 times negative 1 is negative 2. 13 take away 2 is 11. Make that negative. 23 take away 11 is 12. 12 times minus 1 is negative 12. Now, I've been very fluky today. It doesn't always take me a first attempt to do it. 12 minus 12 gives me 0. So we now have another factor. So our first factor from the above was x minus 1. We then just used this factor. So minus 1 in the table becomes positive 1 in your bracket. And then your new quotient is 2x squared plus 11x plus 12. So now we're going to try and factorise that. Brackets for 2x squared will be 2x and x. Numbers that multiply to 12. I think it's some combination of 4 and 3. If I put the 4 there, 2 times 4 is 8. If I put the 3 there, it'll give me 3. 8 and 3 make 11. Everything's positive. So there is that original polynomial in fully factorised form. So it started out as a power 4, and all those numbers multiplied would give me 2x to the power 4. So that's me showing you how to show that something is a factor and to show how to fully factorise. The one thing that I've missed out on this one is I didn't write my sentences, but technically the question didn't say show that it is a factor, but it is really good practice. So what I should have done up at this point here is said that my remainder equals 0, So x minus 1 is a factor. And then I should have done the same again with the x plus 1 and said it is a factor. But if the question doesn't ask you, show that it is a factor, you would possibly get away without writing the statement. But again, it's one of these things that is just good practice at higher, okay? So, access to higher textbook, I would suggest going to page 113 and trying question 2 from there. Thanks very much. Bye-bye.